All right, fellows. So let's start our discussion. Let's start by understanding what is the meaning of statistics. So I'll just put it up over here. Let me start using annotation. I think we are discussing the topic statistics for data science. This is the topic that we have, statistics for data science, and of course analytics. Right, so I think it's better that way. Cool. Now let's try and understand what is statistics over here. Statistics is the branch of mathematics which deals with extracting objectivity from subjectivity using large amount of data, or we can say numbers. Right. See, the entire business world, if I talk about the entire business world, works on one thing that is called as uncertainty. And not only business world, even the even the medicine world, even a lot of industries are there. And uncertainty is something which probably cannot be avoided in a lot of industries and a lot of workplaces, right? Now, if there is something which can reduce that uncertainty and hence reduce the risk and hence increases our confidence on few things, right, that is gold dust for us. And statistics actually does that. It's that branch of mathematics which deals with objectivity. The objective over here is nothing but, let me do the rough work over here. I'm talking about information. Right, I keep on saying this, guys, in my sessions as well. Please pardon my handwriting. Okay, so information and information based, or I mean extracted from where, right? So there is a data, or I think we can call it numbers or data. I think it's better to call it data, because as a data analyst, we should not call them numbers. There are data over here, data in a slightly structured format. Now we process the data something called as through something called as stats, okay, which leads us to certain level of information. This is the tool. So stats is nothing but a set of mathematical methods, mathematical knowledge, mathematical tools, mathematical prescriptions, mathematical ways of extracting information from data. The information over here is the objectivity which I was talking about. Subjectivity is the subjectivity involved in the universe, which we are trying to measure through data. Okay, so a large amount of numbers, large amount of data leads us to certain information, and the tool which helps us do it is statistics. Make no mistakes, statistics is not related to only mean, median, mode. It goes very deep, and that's what we are going to basically look into. Okay. Whereas if I look at the branch of mathematics, there are two kind of statistics. Broadly, there are two kinds of statistics. One is, of course, descriptive. The other one is inferential, right? Now, if I look at descriptive statistics, let me just try and take this up. Yeah, I think it's better now, right? So if I look at descriptive statistics, what descriptive statistics actually leads is, it describes a certain data, right? If I just, I think it's better. It describes, as the name suggests, it describes the data, right? Describes the data. So descriptive statistics actually helps us, it helps in our understanding of the data. So it helps us understand the data, and I mean, please don't undermine the sentence. We need to understand the data. For example, if I collect the age of all the people in, let's say, I think given this example in few classes as well, that all the people who are in a guitar class, let's say guitar learning, so these are the people who want to learn guitar, and they're in a class. Now, if I want to understand the entire bunch of people over here, right, descriptive statistics helps us do that. Okay. Now, descriptive statistics, once I deal with this, I think, first of all, the way of describing is, there are many ways through which descriptive statistics helps us understand, data. And if I may just draw it over here, I think we are talking about measures of central tendency, right? Measures of central tendency, and we have something called as measures of dispersion, and finally we have let me call them measures of correlation. Okay, so which means that these are the three various ways through which we try and understand our data. We try and find a central tendency of the data. What do you mean by central tendency? Central tendency is nothing but something which can represent the data, right? It's a representative of the data, right? So the point is, I mean, what we have heard of mean, median, mode, what are they actually? They represent a data, because I can talk about the entire class using the central tendency. Let's say if I come back to that guitar lesson class, if I look at it and if I say the average age of the class is 32, we can say that most of the middle aged people, we generally tend to say that most of the middle aged people, or people in the line of 30s, perhaps people in the age of 30s, are in that particular class. Although that might not be completely correct, but that is how we tend to do it. So measure of central tendency can help us define a certain group of data over here. Measures of dispersion helps us understand how much data is spread, right? Because that is also very, very important for us to understand, because central tendency alone will not be sufficient for us to tell us that what the data is all about. If I say average age of a class is, let's say, 18, unfortunately doesn't tell us a lot of things. There's a reason for that as well. Okay, for example, if I just give you a simple example over here, let me go for the whiteboard and let me try and put it up over here. What I'm trying to say is that if I say the average age of a class is, let's say, 19 years, now it might so happen that most of the people are in or around 19. For example, the class may be something like this. Let's say, for the sake of simplicity, I'm assuming that the numbers are only 5. There are only 5 people in the class. So I'll go for something like 18, 18, 19, 20 and 20. If I say these are the ages of the people in that guitar class right now, I can say that the average age comes out to be equal to 19. On the other hand, I can also have a class which can have something like 14, right? Then we have 15, then we have 23, then we have, let's say, 30. Is it too much? I think 29, 52. Yeah, I think it is too much. So I'll go for something like, let's say, 24. I think it's better to go for 24. All right, I'll go for 24. So 23, 24, let me adjust the fifth number over here, 14, 15, which is 29, 52, 76. I think it comes out to be the same thing. So I probably will, reduce it down. For example, let's say there is a kid of age 10 years. Oops. There's a kid of age 10 years. There's a kid of age 12 years. Right. So 10, 12, 15, 23 and 24. Right. So I'm trying to do something, guys. Help me do that. Right. So 10, 12, 25, which gives me 37, 70, and I'll go for another 14 over here. Now once we calculate this, all right, so 10, 12, 14, 15 makes it like 10, 12, 22, 27, 37, 41, and 23 is going to give me 64. Okay, just let me add it up. So 10, 12, right. So if I take this, guys, 10, 12, 15, which comes out to be equal to 22 plus 15, 37, 57, 60 and 74. Let me just make it like 16 so that we can make it 76. Now, my point is, these two classes, both of them have an average of 19. Have an average of 19. And we can say that here you can comment and say that most of the people in the class are in or around that particular data point, are on or around that particular data point called as 19, right? Whereas here in this case, none of them are close to 19, yet the average is still come out to be 19. So just a simple example that measure of central tendency alone will not be sufficient for us to comment upon the data, the entire understanding of the data. And this is where the next element, which is our measure of dispersion, is coming into picture. This is where our measure of dispersion helps us how much spread how much is the data spread, so that we can understand along with the central tendency how much is the data spread, and we can take appropriate calls and understanding of the decision. Then we can also start with understanding the relation between more than one variable. For example, there is a variable x, there is a variable y, how these two variables related to each other, that can be defined by correlation over here. Okay. Now if I move forward and move on to inferential statistics. Inferential statistics starts with a lot of things. I think the most important being, as the name suggests, let me first make you guys understand what you mean by inferential statistics. Inferential statistics simply infers from data. So point is, our understanding of the data is done. Now what I want is, I want to infer something out of the data, and that is where inferential statistics helps us do that. All right, it helps in drawing further information from already present info or present info. Right, now if I just make some space, guys, oops, this one, and try and make you guys understand what we mean by inferential statistics or the various branches of inferential statistics. We start with the most important one, which is hypothesis testing. But let me just hold that for a moment. I think we'll start with something which is, if I look at inferential statistics, let me start with something which is slightly more fundamental, which is, let's say, understanding of what do you mean by population and sample. We'll move on to something called as estimation, and then comes in the most important portion, which is hypothesis testing. Right, then we have something called as a regression, and of course then we can talk about something like ANOVA, analysis of variance, and chi-square. Right, while doing this in both descriptive and inferential, we'll definitely move on to a lot of case studies. I love taking case studies in numbers, and I think we'll do that. I'll move on to a lot of practical case studies, and help you guys understand what do you mean by this. Okay, now in inferential statistics, there's inference of a population from a sample. That is the best thing that we actually can do from inferential statistics. We'll move on to estimation, which leads to both point estimation and interval estimation. Okay, we'll move on to something which is very, very important. I think this is an extremely important portion. Let me try and highlight it in my own way. This is my hypothesis testing over here. This is the one which is, let me send it to backward. Right, very, very important. Right, hypothesis testing, extremely important. Right, because a lot of branch of statistics, in fact, it's not just one branch. Once you understand this, you can apply this in variety of things on statistics. And if we understand this, the rest of the statistics from here, in fact, almost entire inferential statistics uses hypothesis testing. Brilliant thing. Then we come across to something called as regression. Regression helps us predict the numerical value based on its own past values. Very interesting. ANOVA, as I've already mentioned, is analysis of variance and chi-square. Well, it's better that we start with the definition of these two when we actually get to these two, and we'll see the practical application of this. They might sound like something which is very, very technical, but trust me, the entire statistics is not practical. Sorry, it's not theoretical at all. It's very, very practical. It's very practical. Okay. So we'll move on to that. Let me start in the next video. We'll start with descriptive statistics. We'll try and understand what do you mean by measure of central tendency, and we'll see the limitations and the advantages of measure of central tendency. We'll move on to measures of dispersion, and then we'll move on to measures of correlation, and then perhaps we'll move on to the inferential statistics, moving on to population sample, estimation, regression, hypothesis testing, and finally ANOVA and chi-square. Now, by my estimation, I think a total of around 10-15 minutes video of 30, 35, 40 videos will be more than sufficient for us to describe the entire statistics. around 12 hours of content is there, so we can see that around 50 videos will be more than sufficient for understanding the entire statistics from scratch. All right, guys. So yeah, let's start with descriptive statistics in the next video. See you guys there.